This talk will be in English. Hope that's all right with everyone. Quick introduction. All right, I see people appreciating that. A quick introduction from my side. My name is Attila Narin. I'm with Amazon for about 8 years. I'm currently responsible for what's called solutions architecture. We basically help customers be successful on the Amazon platform by helping them with their architecture and moving systems into the cloud. Today's talk is about disaster recovery. Can everyone hear me, by the way? Should I use the microphone, or is good enough? Huh? Okay, perfect. All right, today's talk is about disaster recovery, and I'll explain a little bit about some of the, agenda slide here. We'll briefly cover what disaster recovery is. We'll not spend a lot of time on that, and really we'll focus more on why Amazon Web Services is very well suited for disaster recovery, some of the services that are typically used, and then since I'm a technical guy, I want to show you a couple of architectures on how disaster recovery can be implemented. And last but not least, a customer example and a couple of next steps. All right, so let's jump straight in. What is disaster recovery? And I wanted to start out positioning it against archival, backup, and disaster recovery. So let's talk briefly about what is different, because oftentimes these are thrown together. So archiving is about long-term storage of data that may or may not be used again, often kept for compliance reason or just because you need to keep the data for whatever reason. And oftentimes it's not expected that you need to get back to that data. Now backup is a little bit different in the sense that this is data that you will probably use in some fashion or the other, either to restore a system or to go back in, to a certain point in time. So, backup is slightly different, but backup alone is not disaster recovery. So backup is an important part of disaster recovery, but it is not disaster recovery by itself. So let's talk about what is disaster recovery. It's really the process around restoring a system back into operation. And it has clearly the backup and archival element, but also all the procedures to get it working again. So quickly, what are examples of disasters? And those are some that happened in the last year or two: floodings, mudslides, earthquakes, and businesses are getting more and more concerned about this worldwide. And with any kind of reasonably sized IT organization, you want to think about disaster recovery. And actually, one interesting cause is also human error. What if somebody drops a table in your production system, database system? What if somebody makes a mistake and brings down the system? That could also be considered a disaster in that sense. All right, two important terms I want to introduce in the context of DR. There is the recovery time objective, or RTO, and that really dictates how quickly after a disaster the system has to be back in operational order. And a sweet spot in the industry these days is about 2 to 4 hours. Businesses are okay with that as a sweet spot. But you can optimize it by making it designing a system so it has an RTO of 1 minute, 15 minutes, or even a day or two. For my personal blog, quite frankly, a day of an RTO is probably sufficient, because I don't want to get into a lot of costly options. Now, the recovery point objective is a little different. That tells me how much data I can lose in case there is a disaster. So think about it. If you take incremental snapshots every hour, then your RPO would be 1 hour, because the last snapshot is possibly up to 1 hour old. And for transactional or financial systems, you will probably want to go for an RPO that's close to 0 or even 0. But that has implication on the infrastructure as well. So what's really nice with Amazon Web Services, we give you the tools and building blocks to build the system as you need it. Typically the way it goes is that business gets together with IT and decides what is the right RTO and RPO measure based on the business need. Of course, with better metrics, you will get end up spending more money. But that's a trade-off and a choice that you can make, and AWS makes that possible. So, why AWS? Well, let's take a look what's typically required for disaster recovery. You have a primary site with all these different things, right? Routers, firewalls, servers, infrastructure, and so on. And for the disaster recovery side, you will need a secondary site with all these systems ready to go, installed. It needs to, really mirror exactly the primary site, else it will be difficult. So that's expensive. And what's difficult here is, financially speaking, is that the secondary site is not really used unless there is a disaster. And quite frankly, a disaster doesn't happen that often, but when it happens, you want it to be ready. So with Amazon Web Services, one of the simplest ways to get started is to basically just use storage, snapshot storage. So move data in, take a backup, and all these other systems are dormant, switched off basically. And if a disaster happens, you can start virtual machines, virtual instances, bring the system back up, and make it run. And I'll talk you through some of those examples. And really, the advantage here is that the cost of the secondary side will go down. This point here is important. There is a spectrum. I briefly talked about it already. There is a spectrum from simple and inexpensive to very good RTO and RPO. So for a simple system, you just want to move backups into the cloud, and when disaster happens, you basically restore from backup as you would restore your computer or your laptop from backup if needed. Now, if you need to go for better RTO or better RPO, it moves you down the slide of more complexity. We can talk about hot standby configurations where you have two systems running side by side, and if disaster strikes, you fail over to the secondary system. So that's the nice thing again with AWS, that we give you the choice. Again, the choice about regions is also there. We have a couple of regions worldwide. The one closest to us is up in Ireland. So any kind of data that needs to reside in the EU, this is a great region to put the data in. And what's important here is once you pick a region and put data there, the data stays there. And that's pretty important if you have certain compliance things that you need to make sure you adhere to. So that's important. The smaller dots are called availability zones. Think of those as data centers. So in each of these regions, we have multiple availability zones. In Ireland, we have 3 of them. So this allows you further to build durable and fault-tolerant applications in the cloud. That's probably another topic for a whole other talk. So let's stay on track for disaster recovery here. I briefly want to talk about what services are most commonly used for disaster recovery in Amazon Web Services. We have about 30 services. It will be exhausting to go through all of them, so we're not going to do that. I'm just going to speak about some that are most likely going to be used for disaster recovery. And there are really 3 groups. There is storage and how to get data into AWS. Up here we have the Amazon Simple Storage Service, or called S3. It's a great service to durably store static objects. So a great place to put your archives, your backups, any kind of data files that don't change by the minute. So it's actually a great service for that. AWS Import-Export, that makes it easy to bring data into Amazon Web Service. You can actually send us a storage device, and we will plug it into the data center, plug it into the network, and move the data directly into S3 or some of the storage systems. So that makes it very convenient. If you have a lot of data, then it makes sense to go that route. The AWS Storage Gateway service is a good system for on-premise applications that need local storage, and which you can in the back basically store on AWS and make backups there. So the system makes basically exposes a local drive, and in the background backups are happening into S3. So that's a very interesting option as well. All right, networking service. I have another slide on that in a moment, but there are a couple of options. Direct Connect allows you to connect your data center to AWS, gives you more control. Networking teams typically like it because any kind of best practices or security policies around the network immediately apply to the cloud as well. Amazon VPC, or Virtual Private Cloud, that's another way to basically take a part of the public cloud and make it private to you. You can bring your own IP addresses. You can configure the network as you wish, and it's really your area there to put your system into. Route 53 is our DNS service. In the context of disaster recovery, it's important because it lets you shift traffic from one location to the other. So that becomes important in this context. Some of the other foundational services, EC2 or the Elastic Compute Cloud, this gives you virtual machines in the cloud. You have root access or administrator access to this. You can configure and set up the system as you would in your own data center. And what's important for disaster recovery, though, is you probably want to automate this. When there's a disaster, you don't want to log in and install things. You really want to automate a lot of this so that system comes up and runs within a couple of minutes. And this is what customers typically do. We have a relational database service. Again, we have quite a few database offerings, but I just wanted to call out this one. With the relational database service, or RDS, you basically get a hosted version of MySQL, Oracle, or Microsoft SQL Server. So you choose which database you like, and we go through the details of provisioning the infrastructure and getting the database to run. You have quite a few options there to set it up in a multi-AZ setup for increased durability, and quite a few options that basically you don't need that many database administration skills anymore. We take care of some of that heavy lifting. The last one here is Elastic Block Store, or EBS. With Elastic Block Store, you have the ability to attach storage volumes to EC2 instances. Think of it as me attaching a USB external hard drive to this computer here. The advantage in the DR case is that I can take the drive, store it somewhere, and when I need to recover or run the system from that, I can basically provision the equivalent of a laptop, which is the instance, and get this thing to work so that in the non-DR case, I don't have to pay for the compute hours. And I'll show a couple of examples in the architectures. Slightly more detail on S3 and EBS. S3 is designed to be extremely durable, and these are 11 nines of durability. Just to put this in context, what the heck does it mean, 11 nines of durability? Well, statistically, let's say you have 10,000 objects and you store them for 1,000,000 years, you might lose one. That's very good. Think about it. That's probably as durable as you need any data to be stored. In terms of data size, 1 byte up to 5 terabytes, so very suitable for just about any size backup or archive that you need to. On the other side, Elastic Block Store, a little bit more detail. This is again the equivalent of the external drive that I can attach to instances. A really nice feature that is important in this context is the ability to snapshot. So it's not a spinning hard disk. Think of it as more of a system that is a snapshot. It's also stored in S3, and if you need to recreate a volume from that, you can do so. So that's quite interesting. A couple of stats. This is quite impressive. In Q2 of this year, S3 surpassed the 1 trillion object mark. So that's the count of objects stored in S3. That's quite interesting. In the early days, we're excited about every kind of 1,000 increment or the 100,000 threshold, and now it's 1 trillion. So wow, it's growing quickly. In terms of transactions per second, 750,000 requests per second. Sustained load. So it's a big system. The point I'm trying to make here is that S3 is a proven and solid system that's been around for a couple of years now. Recently, we introduced Amazon Glacier. This is very interesting because it changes the price point for storage. It really brings it down to 1 cent per gigabyte per month. And that is very, very, very aggressive. What you trade off here, you still get 11 nines of durability, but the trade-off is that when you need the data back, you have to wait a couple of hours. So it's not immediately available. But this is for any kind of long-term storage options where you're not even sure if you ever need the data back, is actually a great, great way to take advantage of a lower cost offering. Briefly about the networking options. I think I covered some of this, so I'll be brief here. Direct Connect lets you connect your on-premise data center to Amazon Web Services. VPC gives you a secure channel, IPsec tunnel between your data center and Amazon Web Services. And the Virtual Private Cloud lets you basically take an area of EC2 and bring your own network policies and IP addresses and so on. There's lots more detail on that. One point I want to make is Amazon Web Services really provided a lot of sophisticated networking features along those lines. So if you're interested in networking and if that's your background, please read some of the online documentations and white papers that we have. It's actually very rich. So, all right, let's jump into some of the architectures. And they're kind of 4 big patterns, or we try to reduce it into 4 big patterns. Today we're going to cover 3 of them: backup restore, the pilot light, and warm standby. So let's kind of jump straight in. Backup and restore is one of the simplest patterns to get started with. Really, it means you take a backup of your system, move that into the cloud. If a disaster happens, you can decide to either restore that to another on-premise data center or restore it into the cloud. And oftentimes if you have a single data center, if a disaster happens there, you would probably restore it in AWS itself. What's the advantage here? Well, it's really, really cost effective. You only pay for the storage of the backup. And the RTO and the RPO is really dictated by how often you refresh the backup, and it's dictated by how quickly you can restore from backup. Yeah, typically a couple of hours, maybe a day, depending on the complexity. That's just a chart of how it flows. You take a backup, move it into S3, and for any kind of longer-term storage where you're not even sure if you need it still, you can move into Glacier for more optimal cost. And what's important, though, is you have to practice, again, disaster recovery is not just backup or archival. Disaster recovery is the complete set of policies and procedures to get the system running again in case of disaster from those backups. So, as part of this, you have to detail the operational side of this, like how does a sysadmin go back and get the system running again. So that's important. If you look at the architecture here, here we have an on-premise or colo system. You basically take snapshots from the database and create images. Again, these are the snapshots that allow you to boot systems from. So this is a really good way to basically get everything ready, move your data into S3, and then when disaster strikes, let's say it's a blank slide. Wow, okay, too bad. So what the slide would have shown is basically that this side goes away. The same system gets restored to either AWS or on-premise, and then DNS will be routed to that location so that production traffic continues. There's one good, we have quite a few partners in this space and quite a few solution providers. Oracle is one of them. So if you are running an Oracle database, you can use Oracle RMAN in combination with the secure backup module. And you can configure that to basically say, move my Oracle backups into Amazon S3. So that's one example. There are quite a few other systems and solution providers that offer systems or services to move backups into S3. All right, let's talk about the pilot light. The pilot light, why is it called pilot light? That's kind of a silly name, but the analogy we wanted to provide is that of a gas heater. Think of the small light that's always on in the gas heater is called the pilot light, and when you want to switch on the heater, you basically turn on the gas, and then the pilot light lights the rest of the furnace, and it kind of saves you from going and using a match or switching on the your system manually. And what this means in context of disaster recovery, think of the pilot light as the core set of data that gets the rest of the system back running again. In many cases, that's your database, that's your state. So what customers have set up is basically replicate all the data you need as the pilot light, but don't switch on any of the other infrastructure, mostly stateless infrastructure around it. Now, when disaster strikes, you can scale those systems within a few minutes. You can switch on instances, you can configure networks, you can configure all the things that you need. But the point is, when it's not in disaster recovery mode, you pay very little. You only pay for the pilot light, which is maybe 1 or 2 EC2 instances and not the entire infrastructure. Yeah, I think we can skip over this. Let's jump straight into the architecture drawing here. So again, here we have a on-premise data center. We see here the database synchronization or replication. So this is the pilot light here. This is in the cloud and is up to date with the database on-premise. You see that further backups are made into S3 just for extra durability. What we saw previously here as well, these are the images or snapshots that basically correspond to your database server, your app server, and your web server. And now if disaster strikes, let's hope that slide works, perfect. These are actually used to create these servers within a few minutes. So basically this gives you an RTO of a couple of minutes, maybe 10, 15, 20 minutes, depending on how long it takes you to launch these systems and get the caches warmed, get all the system ready. And then you can switch DNS over to the DR system. Yeah? So very, very powerful in that sense. All right, let's briefly talk about the warm standby in AWS. It's actually quite similar to the pilot light. Let's take a look how this looks. Again, we have the on-premise data center. This looks familiar. The database is being replicated. All this stuff has not changed. What's different here is these instances are now running. They're not taking production traffic, but they're running, ready to take traffic. And the advantage here is that the moment I switch over my DNS, that system is taking traffic. So we're talking about an RTO of close to 0 or sub-minute, as much as it takes you to detect the failure and switch traffic over to the system running in AWS. And you probably guessed how this looks like when a failure happens. Basically DNS gets switched over and these instances all of a sudden take production traffic. That's this. Again, a bit of a simplification, but I want to show 3 of the architectural patterns. What customers really do is they pick and choose variations of that. I'll go into one customer example in a moment. They pick the variation between the pilot light and the warm standby. You really choose, and that's the advantage of Amazon Web Service. You control the RTO and the RPO, and based on how you need it, you basically use the service or the architecture that is required. Let's jump into a customer example. This is Haven Power from England. It's a power company that provides power to small and medium businesses in Eastern England. And they were acquired by Drax Group, and with that got additional customers. And they closely looked at their IT infrastructure now and made sure that it would work with additional users and customers, and also that all the other pieces are in place. And as part of that, they developed a disaster recovery story. They used one of our partners in England called Smart 421. So we have a strong and growing partner system. So if you either don't have the skills or desire in-house to work with AWS at a low technical level, you can utilize some of the partners that help you build those systems. So that's what Haven did in this case. Now, they had 3 choices. They could either use the data center of their new parent company, Drax Group. They could go for a third party, some colo, or rent some data center space. That's tough, because now, if you recall the slide with the primary and secondary side infrastructure, you would have to provision an entire footprint in another data center to take your production traffic if needed. So what they've done is they chose AWS precisely for the agility and cost savings reasons. So that they start replicating systems and then improve the infrastructure around it, and if disaster happens, they can scale up and really only pay when disaster happens. So that's a little bit more details as to What they used, they basically picked the EU region in Ireland. That makes sense for customers in Europe from a latency perspective, from a compliance perspective. They are running everything inside of VPC. Again, that gives them the network control and isolation that is often demanded for enterprise applications. They set up systems for Oracle and SQL Server, so those are all pieces that work quite well, and also for Active Directory and Windows file sharing. So, by this you see, a complete suite of infrastructure services can be moved to AWS and used in the context of DR, but not necessarily, also in general. All right, wrapping up, where to go next? We have a rich and growing partner ecosystem. A lot of these are familiar names and logos in the space of backup, archiving, and disaster recovery. So if you're using one of those systems today, it should be quite straightforward to use Amazon Web Services. We have quite a few online resources, backup and storage, disaster recovery. Just come to our website, and there's quite a few things in addition. We have our blog, Typepad, if you're interested in staying up to date with all the new things happening at AWS. That's actually a great way. I really like how Jeff Barr and some of the evangelists explain the systems. We have quite a few white papers. There's a white paper on DR, on high availability, quite a few. So if you want to read more, please do so. Last but not least, we also have a booth outside. If you'd like to speak to me afterwards, please come and find us, or contact one of my colleagues out there. With that, I want to say thank you. One last point, we're also hiring. So if you know somebody who likes talking about architectures and cloud services, come and find me. We'd love to talk. We have a Twitter account. If you want to stay up to date and follow us there, please do so. And with that, I just want to say thank you for your time. And it was a pleasure to share this with you. I think we're out of time. We can meet outside, and I'm happy to answer questions. Just want to make sure we're ending on time and keeping this running. Thank you very much.